Hello and welcome everyone to another awesome stream. My name is Sayam Pathak and I'm a CNCF ambassador working as Director of Technical Evangelism at Civo, building the next gen cloud platform, a next gen Kubernetes service for you. And so this is my YouTube channel. If you're new to the channel,
Technical
please care to
evangelism at
subscribe
Civo, building the next gen cloud platform.
and please care to subscribe to the channel so that this keeps me going to create the awesome streams that we are today here with. So today we will be discussing about Deckhouse, a very kind of new and shiny product which is out there, open source platform, and we'll be discussing all about that. So super happy with that. And apart from this, we have like awesome streams lined up for August, and we have done awesome streams already till this time. So please make sure you check out all the past streams which are out there. And for this particular session, we'll be focusing on Deckhouse, and we have Dimitri with us who will be introducing you shortly. Before that. Make sure you are nice to each other during the chat or during the whole stream, and you do not kind of use any of the offensive language, or you do not use any of the offensive words. Please be nice to each other so that the stream goes smooth. There are moderators moderating the chat, so if you put anything, obviously that will be removed, but please be nice to each other. And also please make sure that the chat is interactive so that you people you keep asking new and new questions so that we get them answered live. So that is another important point of this particular stream. So today we'll be discussing about Deckhouse. So basically we'll be discussing a lot of things like the motivation behind Deckhouse, like why it actually was built. There are so many things, so many tools out there, and why we need another Deckhouse, another new platform. What actually it is, what are its features, how it works, kind of demo, and then how you people can get also involved in it, because community plays a very important role in driving some of the new open source initiatives. So we'll see in the end if it's super cool. Then obviously then we should drive it, we should use it and provide feedback and obviously contribute back to Deckhouse. So this particular session is pretty interesting because it actually came out very recently, and I saw like some of the overview and some of the things on Deckhouse. Then I was very interested to know more about it, and I thought that the community also would be interested to know more about Deckhouse. So today I'm joined by Dimitri, and he'll be explaining all the concepts and all the interesting facts about Deckhouse. So Dimitri, thank you so much for tuning in, and thank you for joining the stream. Please introduce yourself to the community.
Thank you very much. So my name is, as you already know, Dmitry, and my last name is Stolyarov. That's a Russian name, and it might be a bit hard to pronounce, but we all used to different names with different pronunciations. I am CTO, Chief Technology Officer of Flant. We are middle-sized Russian company. There are 136 us as of today, but we are growing. And the main thing we do is we help people running production on Linux. We are outsourcing company that helps people build their infrastructure based on Linux, based on open source technologies, based on cloud native stack. And we've been doing this for 13 years. I'm co-founder of company, and I've been doing this 13 years with the company, obviously. So that's a brief introduction about me, probably.
Yep, that is awesome. So actually, hearing out from the founders is actually very interesting because they have seen obviously when you think of founding a product, you obviously do a lot of research before that. So you obviously do a lot of research, like what pieces are missing and what are the key focus area that can be turned into a new platform or a new product or a new open source product. So this whole area of interest is very interesting, and hearing out from the co-founders and the founders is really interesting. So I think that's a great opportunity for you all to ask questions directly, because it's coming from the CTO. It's all the research has been done, so all the technology path, all the path to the production has been very carefully observed by Dimitri. So please feel free to ask any questions, and we'll make sure he answers all live. So anything that you have, please ask them in the chat. And I see like folks have joined. So hi Balaji, hi Rutham. So many folks have already joined. And please share the stream with your friends so that more and more folks can join and learn about this new platform. I've shared the link in the chat. So Dimitri, like I was saying, so how about we start with something, the motivation, like obviously you have done some research. So can you tell about those research, like what led to the decisions of creating this project, or what was the motivation behind the project, or what was the exact problem statement that you were trying to solve with Deckhouse?
Okay. To answer that like fully and precisely, we need to go back maybe like 5 years ago or 6 years ago, or maybe 7 years ago, or maybe even more. So everything started when we were helping several companies doing continuous integration, continuous delivery, like almost a decade ago, let's say. And there was no Docker, there was no Kubernetes, obviously, there was nothing. And we've been using sometimes tar archives with a root of operating system, with the truths, with an enormous amount of different init scripts and so on. Sometimes it was deb packages and different stuff like that. And then we started running our own version of Docker because the Linux kernel, at that moment, namespaces and C groups were introduced to Linux kernel. So we started, and there was no Docker, there was only LXC. So at that moment, we started using our own kind of, Docker-like thing written in Python. Then Docker happened, and we were extremely excited, to switch from our legacy scripts and solutions and so on to like good and standardized one. So I think that I would not lie if I tell that from 2014 we've been using Docker, but I'm like, because it was like really long ago, I cannot tell you precisely. And then obviously we started like building things on top of Docker. And I remember the moment when we had a pretty sophisticated installation with a chef as an orchestration and a lot of Docker containers as a basically running thing as a main work nodes, whatever, working environments as a container. So chef as an orchestration, Docker, and it was a mess. It was a mess because it was completely because it's chef, because like any person who did it knows that when you try to introduce new engineer to this project, you had a lot of things to explain, like because everything is custom, everything is everything is custom. And I think that was a moment when we started looking for orchestration like seriously. And we started experimenting with Kubernetes. I think it was version 1.2 at that moment. So we were not like early adopters, but early enough for now. And I think we started using Kubernetes from 1.4, and from 1.6, like we already had some number of installation. So what happened then? We had maybe 20 Kubernetes clusters, most of them on bare metal. At that moment, there was no managed services, or probably only GKE, but you know what I mean. So, and all these installations were obviously different, with a different version of ingress controller, with a different version of Prometheus, with a different dashboards, with a different alerts, like completely sophisticated, not even, not equal systems. So we started some effort internal of fighting this entropy, fighting this chaos. and trying to, unify and standardize all the installation. Like, okay, let me install Prometheus from one source and make it absolutely identical in all the installation. Let we think of how we will do update, like centralized update of the Prometheus in all the clusters. Let me do the same with ingress controller, and then step by step in last 4 years we built this product. Not really. Of course, we were thinking about releasing it open source. We were thinking about creating this as a separate project. But the main goal, always, all the time, was like to automate, to improve our efficiency, to just unify all the installation. And as of today, we have, I think, almost 200 clusters. Half of them are running on bare metal. Half of them are running on AWS, GCP, Azure, OpenStack, VMware, vSphere, and like all kinds of imaginable infrastructures in different countries, in absolutely different environments. And we have a team of 10 good engineers who are responsible for not really maintaining these clusters, but for creating new versions, basically writing new software, new features. And we know that we can maintain all these 200 clusters with only one skilled engineer. So that's why we call this kind of NoOps, because it's constant amount of operation is required for us to build any amount of clusters. So that's kind of brief history. So it was not really a research, any like real, we gonna do this or we not gonna do this, because at some moment we were using like kubeadm. Sometimes we were using kubespray. Sometimes we were using, what was the name?
Kops.
Kops. Thank you very much. I don't know how. Like, yes, it was Kops for AWS, but it was like there was support for GCP, and there was like effort of creating this support, but we never used Kops with anything except AWS. So, and like all this chaos and like different versions, different approaches each time. So we basically slowly, step by step, build a system that is completely identical on any platform that we need. So that's the story behind Deckhouse.
Yep, that's pretty interesting, because it's actually coming from your own challenges, your own challenges, your own building building the clusters again and again, your own day-to operations that are needed to run all these clusters, provision the clusters, and then maintain the clusters over the period of time. Because it's not something like you just spin up a cluster using kubeadm and then it's over. Actually, it starts over there. So it's the
Yes.
thing. It's just the beginning over there. So whenever any one of you in the chat will be spinning up a cluster, don't think that your mission is accomplished. Actually, it's just the beginning. So you just have put your foot into something very dangerous over there. So actually, the day two operations are really very important, especially the observability piece, the security piece. They are super hard, super important to implement the right way. You can actually consume tons and tons of resources without knowing when you implement observability piece by default. So if you do not tune the settings right, if you do not set the things right, set up the things right, then it's very difficult. So obviously the day two operations are very challenging, and as Suma is also mentioning, it's always a challenge to manage the day two ops. So it is. And so a few things just before we move to the next section is, first, I read in the chat like a couple of folks are there who do not know much about Kubernetes. So I recently launched a course on Civo, which is civo.com/academy. It's completely free of cost. No credit card required, no strings attached, completely free of cost by the folks at Civo. So make sure you go check it out, learn Kubernetes. So it's very simple. You can know all the concepts from beginning. After that, Next is today we are doing I'm doing one giveaway, which is a CNCF store coupon of $30, so free shipping worldwide. So you will be able to order anything from store.cncf.io. To enter, what you have to do is you just have to tweet about the stream, tweet about what you are learning from the stream, and Saloni in the chat is moderating all the Twitter and will be telling me the result, which I'll be telling at the end of the stream. So please stay tuned till the end of the stream. It's actually very awesome. If you go to store.cncf.io, there are amazing swags which are out there, and it's completely your choice that you can buy from that. So shout out to CNCF for that. And yeah, so Deckhouse is sounding pretty interesting because it's coming from the experience over the years of using no Docker, no Kubernetes, to Kubernetes, and then evolving from there to a product. So it has actually matured. It actually matured internally, I would say, and then it has been open sourced now for the usage. So it is carrying its experience and the features. So yeah, exactly the same question that I was about to ask, like over the years, how Deckhouse has evolved and what are the best features. So we are going into next, like what actually Deckhouse is now and what does it offer.
Okay.
You want to share this, share the screen?
No. I
That you
think
have?
that I start
Okay.
just with a basic explanation.
Okay.
The core of Deckhouse is a thing that we call shell operator. We actually have done a talk on one of KubeCons before about shell operator. It's SDK for building operators just by using shell script. So basically, it allows you to subscribe for any object that exists in Kubernetes and run hooks and such things. So it's like very simple, very thin piece of code that allows writing hooks on shell or Python or any interpreted languages. Then there is a bit larger piece of software which we call a DON operator. It includes shell operator inside, but it's a shell operator plus Helm plus Helm. So basically, you need to have like folder having Helm charts, and each Helm chart has it's a normal Helm chart, but as extra, it can have hooks that can discover values for this Helm chart, and that can like not only discover values initially to install Helm chart, but also run continuously and react on the changes in Kubernetes. For example, like if you create a custom resource in Kubernetes, these hooks can subscribe for this custom resource, notice the change, and trigger the Helm reinstallation. So, for example, you will roll extra software. So, at the core of Deckhouse, there is two open source projects, Shell Operator and Add-on Operator, both written by our engineers, and both open source not many years, but several years ago. So we were like open sourcing the core technology, but not sharing our charts because it was at that moment it was not meaningful enough. So like to publish project, you need to do several things differently. But we were quickly iterating internally. So basically, Deckhouse is operator. You can install it in the. Let's go simple. We have existing Kubernetes cluster. For example, GKE or EKS. You can install Deckhouse into existing Kubernetes cluster, and it will be one deployment with just one deployment. And then this deployment will install you Prometheus, install you all our dashboards, install you different things, different things that we think make Kubernetes production ready, ready for day 2 operation. But that only like half of the whole story. The other half of the story, if you don't want to use like manage Kubernetes at the lower level, if you want to install Kubernetes just by the Deckhouse. So to do this, Deckhouse does some magic, which I can explain, but I think we can leave this for later because it will be too hard. So Deckhouse is an operator which is responsible for all the software in the cluster and for the cluster if it's installed by Deckhouse, and it updates it. It checks all the component and basically is responsible for the cluster. That's like very short explanation. What do you think? Should I go deeper or?
Yeah, so basically, I was just searching and I have pasted the links as well for the shell operator and the add-on operator. So I think they itself
Have you
are the
found them,
interesting.
or sorry? Have you found them, or should I?
Yep. I have already pasted the link to the
Thank
community.
you.
Yeah, I think so. Rightly said. As you said, like the core technology is based on the add-on for shell operator and for the add-on operator. So these are the core pieces which are being used. And right now the platform itself is open source that you can install the community edition in your clusters. Yeah, let's see like what it features are and how it works, like what are its main features. Can we have a look so that we have a proper understanding, like okay, this can do this stuff, and all these things. And if possible, we can maybe go through the architecture as well if it's there already.
Yeah. If can you share my screen? Oh, thank you. We have this very like high level picture of how we see the whole story. So, and we think of it as of three levels or three layers. Basically, at the bottom we have infrastructure level or layer. Then we have cluster layer, and then we have platform layer. And if we use like non-cloud, for example, bare metal servers or virtual machine just statically provisioned in some old-fashioned non-API virtualization, like many enterprises, many old data centers still have either very non-cloud friendly virtualization systems, or that with just like two custom APIs, not common APIs. So we can run Deckhouse on static machines, on bare metal servers or static virtual machines, or we can run Deckhouse on top of Google, Azure, OpenStack, VMware, AWS, and the Russian cloud, which is called Yandex Cloud. It's actually the largest cloud provider in Russia. So then, if we talk about cloud part, on a cluster level, we have a Terraform, which creates all the required components, all the required things in the cloud. Which things are created depends on the cloud. For example, if we open AWS, for AWS, I think we have only one layout. Let me check something different. Maybe it will be Google. Oh yes, for Google we have different layouts, and the difference is in one layout, working nodes in cluster have external IP, and in another they don't. So basically, what Deckhouse does is, by utilizing Terraform, it creates route tables, subnets, CloudNet, and whatever you need in the selected infrastructure. Like we call it base infrastructure. Then we have a component which is called Machine Controller Manager. It's a part of I think Gardener project, Machine Controller Manager. Yeah, Gardener Machine Controller Manager. I would call it, it's like sibling project to Cluster API, and for historical reasons we started using Machine Controller Manager instead of using Cluster API, and now we want to switch because like it's better to use more common thing, and we are on the way to do this transition, but we will hide this from our users because we know how to do this. How to hide this from users. It's just like hidden internally. So basically, Deckhouse automatically creates virtual machines, and also Deckhouse installs cluster autoscaler, which scales the cluster. And by using Machine Controller Manager, we see no difference between different clouds, because for us it's same as like you have in Kubernetes. You have deployment, replica set, and pod. With Machine Controller Manager, we have machine deployment, machine set, and machine. So cluster autoscaler implementation is much simpler for us because it doesn't need to go to the cloud and change number of. It doesn't need to contact cloud API. It just needs to contact Kubernetes API and change number of replicas in object inside Kubernetes. And so like I don't want to overwhelm you and go too deep, but basically if we install Deckhouse on top of cloud, you automatically have all the infrastructure, all the virtual machines, and you can manage them by custom resources. So I can show you, for example, for a Google, if you're talking about Google, we have a custom resource that describes class of instances that will be created in the Google, and the size of the root disk, the type of the disk, image to use for virtual machine, machine type, for example, N2 custom, whatever, and whether this machine is preemptible. So, and we have like the same not the same, they all are different, they all have like specific for each cloud, but more or less same resources for each cloud. And then we have one resource that describes the group of nodes. So it's easier, I think it's easier, just a second, I will find example. Yeah, that's much easier to look at this example. So node group, which has minimum per zone 1, maximum per zone 2, and it references the instance class. So just by creating 2 resources in Kubernetes, you can create new node group, which will be automatically scaled. So that's kind of low level of Deckhouse. And also it brings all the components like Cloud Controller Manager, which is responsible for creating load balancers in cloud, like CSI, which is responsible for ordering disks and mounting them between nodes and so on. So that's the lowest level of the Deckhouse in cloud. If you talk about bare metal, when we run Deckhouse on bare metal, one important thing that I forget, like completely forget. Deckhouse on each virtual machine installs agent that sets up all the software on the virtual machine, like Linux kernel, Docker, kubelet, and like all you need on the virtual machine. This is a very simple component. Basically, it connects to Kubernetes and downloads bash scripts from Kubernetes API and just executes them on the node and reports back status of execution to Kubernetes API. So like everything is controlled from Kubernetes API, even things that are installed on nodes. So in cloud, Deckhouse creates virtual machine, installs agent on this virtual machine, and then virtual machine is set up like with a kubelet, with Docker, or now we don't use Docker, we use containerd. I forget all the time. I forget to, you know, the Docker is not dying but disappearing in the ecosystem. So on bare metal, obviously, we do not go to the shop and buy. Like Deckhouse doesn't go to shop and do not buy your servers because it's impossible. But you can install agent on the bare metal or static VM, and this agent will like set up all you need, and then it runs continuously. So when we introduce new update, this agent sees, okay, now I need to update containerd from version X to version Y to version Y. So it just like automatically updates containerd. And we know when we publish new update, we know whether this update is, we call it disruptive or non-disruptive. So if it's non-disruptive update, it just rolls out automatically. If it's potentially disruptive, it requires either that you just agree to roll out disruptive updates, and node will be drained, updated, and then put back into the work. So like you can set up this. So then next level, it's control plane management. Deckhouse manages etcd, kube controller manager, API server, like all the control plane components. As I've told you, it managed on node software. CNI, we use Flannel as a default for most of the scenarios, or we use no CNI approach. We have just I don't know, 50 lines of code in Bash that like do not use container network, just utilize routing. Because we are from running production, and we want things to be as simple and as reliable as possible, because like we don't want to bring new overcomplicated technology and then have problems and like do not wake up in the middle of the night and fix something. We want to sleep. We want to we want to live our life. So because of that, like all our decisions are driven to like simplicity and be as simple as possible. But we are going to switch to Cilium, which we don't think is simple, but we think that all trends go that eBPF, and it's just faster, better, and you probably know like all the story behind Cilium. So Deckhouse managed kube proxy, manages kube DNS, managed CNI. So, and by that you have like ready to use vanilla Kubernetes cluster without any extra components. And then comes platform layer, which has monitoring, which has auto scaling and management, and managing resources part, which has like different things for to ease cluster access and so on. So, but like things for security, for example, out of the box, we install DEX as a federated identity provider, and all configuration is done the same way. So if you want to configure DEX, for example, if you want to attach your cluster to GitHub authentication, all you need to do is add one resource in Kubernetes, and your Kubernetes will be automatically allowing user access both to the API and to Prometheus and like all web interfaces by using GitHub as a source of authentication. So that's kind of, you know, overview. Infrastructure level, we utilize either cloud or bare metal. Then on top of infrastructure, we create vanilla cluster, and then on top of vanilla cluster, we create, as we think of, fully functional platform ready to use in production. And Deckhouse is responsible for all these components, for updating them, for checking them, for configuring them, and all the configuration is done by custom resources in Kubernetes. So that's it.
I mean, that's pretty interesting. So you have everything. So basically, Deckhouse is creating the clusters as well, installing. Basically, first it is using the virtual machines from the infrastructure providers, and then it's installing all the required components to set up a Kubernetes cluster. And then it is actually setting up the Kubernetes cluster and joining the nodes and giving you the complete kind of setup for that. And then you have all the pluggable components which you can have, like monitoring is there, and you have auto scaling components, you have network load balancing, you can even have istio service mesh, as I can see on the screen, and you have various authentication mechanism. So you have GitHub, and so you have Dex as well. Also there is like security that can be handled by, so everything is managed by CRDs and everything is managed by Deckhouse. Deckhouse is taking care of that. So the initial component gets deployed on a Kubernetes cluster itself, right?
Yeah,
The initial
if we talk about cloud, you need your, I don't know, laptop, and you prepare 2 YAML files. We actually have like getting started guide, which helps you to create this YAML file. For example, for Google Cloud, there is like presentation explaining what will happen to you, and then you just need to install like domain name you want to use, prefix for virtual machines and things, and then choose one of layouts you wanna use, and then like select whether you want a minimal cluster or you want a multi-master, or you want to like recommend it for production with dedicated nodes for front ends, dedicated node for system components. And then it shows you how to create required roles, basically how to set up identity and access management, like what roles we need for Google. And then you have one configuration that describes like how to install the cluster, another configuration that creates resources, and all you need to do is to just execute one command, and that command create virtual machine in Google, create minimal Kubernetes cluster there, install Deckhouse in the. I think I have a like brief presentation of how it's happening. So like to install the to install Deckhouse. Yeah, we have a presentation. Like I can even just go and read it. To install Deckhouse, you will need a PC and a cloud site. So by using this guide on our site, you create two YAML files, and then you just run one command, and this command, by using Terraform internally, creates all the basic infrastructure, and then create first virtual machine, and it installs on this virtual machine Kubernetes cluster, and then installs their Deckhouse, and then Deckhouse runs and create all the other nodes, like control plane nodes, worker nodes. So that's like bootstrap process, and then it leaves. So that's like the overall process. If you are more interested, it's just getting started guide on the Deckhouse IO website.
Yeah, I think how would it differ? So I have two questions in my mind, and there's one from the community as well. So first we'll take from the community one. So do you collect any stats about the external Deckhouse installations, both for CE and the EE versions?
No, we do not collect any stats, I think, by default. We were thinking about it. So we like, basically we want to know like number of installation and so on. But as of today, no, we do not collect any information.
Okay, another one from the community we'll take, and then we'll move to my questions. So how does the agent deployment managed in a multi-cloud environment?
But our approach is that we do not support multi-cloud environments. We think that, like in reality, you never have one cluster working across several clouds. That's just not feasible for real production scenarios. Usually, like if you want to utilize AWS, Google, and Azure simultaneously, you have at least three clusters. So you use Deckhouse just to install first, second, and third, and of course, agents inside clusters are different. Scripts are a bit different, but this is hidden from you, and you have like completely identical Kubernetes cluster with everything as identical as possible. Obviously, like in Azure, you have one set of annotations for load balancer. In AWS, of course, clouds are different a bit, and because of that, you have like different set of features. But that's obvious.
Yep, I think that pretty much answers my question. But there are two more that I would like to add. One is you mentioned about the Gardener project, and there is a concept of shoot cluster and seed cluster over there, where you have the shoot cluster, and then you create those seed clusters which are there. So I mean, I feel like this is kind of similar to that. So how this is kind of different in that scenario? I know there are a lot of components which are not there, like the monitoring PCs and all those pieces which are not there. But how would you, I mean, how you have taken the approach from there, because you are already using the machine controller from that particular project. So how would you kind of differentiate in that aspect?
Thank you for the question. It's like very, very important one. We have a huge difference because in Gardener, you need to have three like to create one, you need to have like central one, shoot one, and the final one. I don't remember the names, but basically, because for the end cluster, control plane is hosted in another cluster. In our case, each and every cluster is completely autonomous and like standalone and has no external dependencies. So if you just need two clusters, you don't need like one in AWS and one in GCP. You don't need to create 5. And I don't know how it's solved in Gardener, but I think that they automatically manage only final clusters, like and the intermediate, like the root and intermediate clusters, you have to manage manually, or like I don't know. Don't quote me on that. I don't actually know how they manage, but like for us, each cluster is completely independent. But we are going to implement this control plane hosting, we call it, like to be able for one cluster to host control plane for shoots, or how they call them. So like base difference is like that. We have many small and middle-sized customers, and we don't want to tie them to like our, for example, we want our customers be independent and be able to leave us if they like don't like our service. So because of that, we create as autonomous and independent installation as possible. So that's biggest difference.
Okay, let me ask a difficult question then. So there is another. I don't know whether you have used that platform. So there is a platform which is Kubernetes. So from Cube One, so Kubernetes platform KKP. So that also does a similar thing of creating the virtual machines and on installing Kubernetes on top of that in a cloud provider with certain set of configurations that it takes. Obviously, first you have to set up the KKP platform. After that, you will be providing your cloud credentials over there, and you will be, I mean, it in the back end, what it does is it creates exactly kind of what you said, like it will create the virtual machines and then install Kubernetes on them with respect to the versions that you have selected and kind of the operations on that as well. So how would you kind of compare to KKP if you have used? If not, then it's completely okay.
We haven't, but like this scenario, what we have done is it's like you should understand, we are not type of visionary people who can see 10 years in the future. We are like very simple engineering guys. We have this like problem here, and problem here, and we don't want to fall into so we create software to just help us in our daily things. So
Cool.
when we were doing this, there was no Kubernetes. Of course, if we were starting now, it was like the stupidest thing now to start building your own platform. It's the
Yep.
stupidest thing you can. That's not
I
correct,
understand.
but
I
that's
understand because yeah,
not
I just
really
want to give
reasonable.
I just want to give the community a view. Like this project is not something that they have just started now. So we should. I mean that
4 years
itself is a
ago.
big. Yeah. So this started 4 years ago when there were no platforms like this, and it has reached to this level, which is helping Flant to for helping their customers, helping their users, and the adoption, the creation of the clusters, and ease out the operations and all those things. Now, why I brought up the Gardner and Kubernetes platform is they are also there. I just wanted to know. I just wanted to see like if there are extra, if there are any differentiators or there are any add-on points which the Deckhouse platform offers. It's completely okay if you haven't evaluated that because you started pretty before that. I mean, obviously it wasn't there for the public to use, but the journey started a long back. And in spite of that, I think it offers a lot of good features, and I really like the intuitive UI that is there, and it is not also storing the information as you said, so you can see how you can generate the YAMLs easily using the deckhouse.com in the getting started page itself, selecting your cloud provider, and then you can easily use those and obviously tweak any of the configuration that you want, and easily apply that. So it basically will create a small cluster where it will install Deckhouse, and after that it will start creating your actual Kubernetes cluster, which will serve your production setup. So do you have Dimitri? Do you have any setup to show this is how it looks like, so that we can have a feel of that?
I think the best thing to show is monitoring, and like just few dashboards of what's happening on inside. Just one note about tracking and this stuff. And like when you use Community Edition, we don't know. But if you decide to use Enterprise Edition and you request
Yep.
access and token, I have some license on the video. That's funny. At the moment when you receive enterprise token, we track your installation, and you can get trial for I think 30 days for free without just by leaving name, email, so you receive it automatically if you want. So monitoring, we use Grafana, of course. And what I want to show you is just like brief overview of what's happening. That's the real production cluster of our own infrastructure, and I am I'm crazy enough to do demos on a production, but that's just a monitoring, and we don't have any dark secrets in this cluster. So the highest level is namespaces, and if you open this dashboard, you can very quickly and easily see of what's happening like in the whole cluster. The first thing you can see is a table describing average utilization in last 3 hours, because it's 3 hours selected. And that's the name of namespaces. And you can see that one namespace utilized 22 cores, the other one only 4 cores. What's interesting is, for example, requested CPUs. We can see that this namespace requested 131 and utilized only 22. And this dashboard says that this namespace over-requested 105 and under-requested 1.2 cores. So at the same time, some workloads in this namespace requested more than they need, and some less than they need. So like if you look from high level, we basically just by looking at this table, we can already work with cluster utilization. Other important things: pod restarts, pod count, like usage by namespace, and like on one side basic stuff, on the other like all important things you see very quickly. But what is really nice, you can click at the name of the namespace you wanna look, and you get drilled down into this namespace. So now we see only one namespace, and we see controllers. We see deployment, deployment. Most of the controllers are. Oh, we have stateful set with Elasticsearch. So like we see all controllers, and all the graphs down are also like usage by controller. So on the first dashboard we have usage by namespace, so we have all namespaces. But when we drill down into one namespace, we have usage by controller, and we can go deeper. But before going deeper, I want to show you this this status map. And it shows that like everything is green, but there are sometimes something yellow, and something yellow says that like 1 to 29% of pods were not ready. So that's also nice. Like you can just dropping eye and see like, okay, I had some breathing, because I like all the workloads breezes. We utilize vertical pod autoscaler and horizontal pod autoscaler a lot. So because of that, like everything is moving and readjusting to traffic. We can go deeper. We can click on a controller and look inside one controller and see pods of this controller. And we see that there was about an hour ago there was a deploy. So all old pods stopped their life, and like many new pods were started. And we also can see that there were some container restarts during this rollout. So just by looking at one dashboard, same, but CPU usage is by individual pods, and we can we can go one level down and look on individual pod. So we'll see like information about container, and here we have only one container, so it's not very interesting. So namespaces, one namespace, one controller, and one pod. So like four level. That one interesting thing in monitoring. The other is information about ingress. Very rich dashboards about like all the traffic coming into your cluster, and with the same drill down capabilities. Like you can drill down in one namespace and see all the ingress resources and services where they distribute traffic, and with very sophisticated information. And you can drill basically you can drill down, like you can select one ingress resource in the cluster on this dashboard, and then look at individual backends. So like you will see response time histogram of each individual backend that is running for this application. So like very powerful tools for observability out of the box, just like immediately. So that's like quick overview of, I think, one very important feature if you really running Kubernetes, if it's not for fun, if it's for real production.
No, I think that's pretty interesting. So just a quick one, like these dashboard will ship, by default when the Deckhouse will be installing the Kubernetes clusters, right?
Yes, you will get
Okay.
Prometheus, you will get Prometheus adapter that connects metrics API from Kubernetes with Prometheus. You will get automatically vertical pod autoscaler that can utilize all these metrics, and you get all the dashboards. And with a Prometheus adapter, you will have a set of custom resources that allows you, for example, if you have, that's example of RabbitMQ. If you have RabbitMQ in your cluster and metrics from RabbitMQ are collected in the Prometheus, you can create like service metric with the name RabbitMQ Qform. So like you can create custom resource in Kubernetes that tells Prometheus adapter to export some data from Prometheus to Kubernetes, and then you can scale. For example, you can set up horizontal pod autoscaler, like to use this service metric to scale. In this example, it's a deployment to scale deployment based on this metric.
Okay.
So
what about the long-term storage? So anything on that?
It's a complicated question. Yes, we install, like by default, if it's a highly available installation, we install 2 Prometheus in a high available setup, and we install the third one. We call it long term, and this long term Prometheus once in 5 minutes scrape one of the main Prometheus, so it stores like information every 5 minutes, and at any dashboard you can select the source. For example, you can use long term, and as you can see, all the graphs lose. So it's now like each step is 5 minutes because it's from long term. It's not really long term. It's just, as simple as possible approach. Several months ago, we've done our first acquisition. We bought a company with the name OK Meter. I'm not used to pronounce it in English because in Russian it's pronounced Okmeter, and I still not used to pronouncing this. And they have a very very powerful core technology for storing enormous amount metrics with a very high cardinality for a very cheap. So in next few months, we are going to launch our own cloud, which will be based partly on Cortex, but mainly on this like core technology. Unfortunately, it's proprietary, but we don't know what to do with this as of today. Maybe we will open source it, but for now we don't have any strategy. So for a long term, we will suggest our clients to use cloud, and not only for long term, but we will suggest our clients to replace Prometheus with just a Grafana agent, like to not store any metrics inside the cluster, to push everything to the cloud, and then. But that will be like just one switch. Either you want a Prometheus in your cluster and you want to pay for several virtual machines and pretty big one, because Prometheus is if you have a lot of metrics, like if you want to have a good observability, you need a lot of metrics. If you have a lot of metrics, you will have large Prometheus. If you have large Prometheus, you have to pay for large VMs under it. So we will give our clients opportunities to either pay for their own infrastructure or pay us for a cloud which is more reliable and costs less, but it's less autonomy. So that's long answer for a short but very complicated question.
Yeah, actually, I mean, this was something. I mean, when you talk about because we have been talking about the production scenario, so this comes with respect to that, and good to know like something cloud like solution with long term high cardinality stuff is very important when you talk about querying the long term storage with high cardinality of data. So there's one question from the community as well, like do Deckhouse plan to add OPA as the authorization policy later on?
Thank you very much for the question. That's, I would say, at the head of our backlog. We wanna add OPA as an engine, and we wanna add simple way to utilize OPA just by like another set of custom resources to like. So like our approach, we still don't have any web interface. We only have custom resources, which is not very good for not professional users, not people who used to like play with the API. But I think after we will have web interface, this integrating OPA is one of the things we wanna work on.
Okay, another follow-up question. I mean, not a follow-up one, but I think you would be happy to answer that as well. Like, what are the extra features shipped with Deckhouse Enterprise?
Sorry?
What are the extra features which are shipped with Deckhouse Enterprise Edition?
Oh, that's easy to answer, and of course I like to answer it because it's money. The easiest way to answer it is to just press in products and Deckhouse Platform Enterprise Edition. And what it gives you is basically OpenStack support and VMware vSphere. That's two main things. Third one is Istio. So all other things are coming soon, and we are working on them. But basically, three main things: it's OpenStack, VMware, and Istio. And if you look in the documentation, you can always like with network load balancing. Yes, all the features that are not in Community Edition, they are marked. Like you always know that this thing is not in Community Edition. And of course, we want to put all the features in Community Edition, but like we need to find some very, very hard to find balance between being able to build sustainable business around it and be friendly for community. I think we will succeed with finding balance, and I hope that you will help us. Like by you, I mean like all the people in the community. So that's the main difference. And of course, with Enterprise Edition, you get our support, which is I think obvious, and you receive service level agreement from us. So we guarantee that not only we will answer your question, but that your platform will work if you follow our instructions and our advice. So we guarantee and pay fines if it's not like that. So like we guarantee platform availability, even if we do not have access to your infrastructure. That's our one of the main selling points.
Interesting. So thank you for bringing that question as well, because now when if you have the needs that Dimitri was just talking about, then probably the Enterprise Edition best fits for you. Yep.
Just so sorry. I know it's a bit like promoting things, but we have two things. You can either use a platform on your own and like use Community Edition, it's free and open, or use Enterprise Edition, it costs something, but not very much. Or you can ask us to manage things for you like fully. So there is a service which is called Manage Deckhouse, and we can manage our platform at any infrastructure of your choice. So that's like two possibilities: either having a platform or asking us to be fully responsible. So like two ways.
Okay. Cool. So I think we have covered almost everything. So with that we have. So I think you can check out the GitHub repositories. You can check out the documentation and start spinning up the clusters using the Deckhouse documentation, which looks fairly simple. So if you have access to any of the public clouds, go ahead and try out, and let Dimitri know how you can how did you find it, what are some of the cool things that you were able to do very easily. So I see like there is 8-minute kind of stuff written, so probably in less than 10 minutes you will be able to spin up a complete production ready kind of infrastructure or Kubernetes cluster. So which is pretty cool. I mean, you don't have to do, or you don't have to go through any of the hassles or any of the abstractions which are there to setting up the Kubernetes cluster, like multi-master, multi-control plane. So it's pretty interesting to see how this will be working. So I'm going to definitely try it out, and I hope whoever is watching and will give a try at least to to see the power, because at this point of time, Deckhouse has been created from years of experience. So it's important to know like how much efforts have been gone to and into the ease of operations. So I'm pretty excited to use that. So I'll definitely use in any of the public clouds. Another thing, so thank, I mean, I see, Rutam, Suman, and Viraj, you have been live tweeting all the things. So thank you so much for that. And for this particular stream, Rutam, you are the winner. So I'll be, just reach me out on Twitter and I'll hand over you the coupon that you can use on store.cncf.io. And Dimitri, I would definitely ask you to check out the Twitter thread that Rutam, Suman, Viraj, and some of the other folks have created on Twitter. I think I see that you are also tagged on a few of them. I don't know if you have logged into Twitter for quite some time now or not, but you are you are tagged in
I'm
that.
I'm I'm like hidden Twitter user. I read it, but I never tweet. But
Okay,
almost never.
yeah. So thank you all for tuning in. It was a great episode, and thank you, Dimitri. It was a great episode as well. And as you can see on the screen, the Deckhouse discussions is open. So make sure you want to discuss anything. Discuss that and with the team, and maybe your feature gets implemented in the next version. Who knows? So that's the power of community. So make sure you do that. And thank you so much, Dimitri, for walking us through the complete journey, features, the installation steps, and some powerful Grafana demonstrations that were really good, especially the status one where you can quickly get to see like which thing went wrong for split seconds or something like that. That was really interesting. And thanks to the community for joining in and asking the amazing questions that you have asked. So yep, please subscribe to the channel and share it with your friends, because whatever tech I bring to this channel is nowhere. So you get everything on this channel. And make sure you subscribe to that. And if you are new to Kubernetes, make sure you check out sivo.com/academy. I'll just type the link once again. In the meanwhile, Dimitri, you want to say anything to the community?
Thank you for your time, and thank you, Sam, for bringing this topic and allowing us to share. It was really nice to talk with you and
Absolutely. Likewise, so it was really interesting product, and I think it's kind of powerful. And obviously, you already have the customers, so they are already feeling the power. But I think the community will feel the power too if anybody starts to implement, in Kubernetes for the SREs or for the developers. They will actually feel it like it's pretty easy. The first hurdles are pretty easy, and after that, they just focus on developing the applications. So with that, we'll just say bye to you and see you in the next stream. Next week is super awesome because we have the whole week WSL series, WSL week. Each day there'll be a session with WSL and containers, introduction to WSL, advanced WSL, WSL and containers, WSL and Kubernetes, and Penguin Linux. So all 5 days, super awesome fun will be there with experts in WSL and Penguin Linux community. So make sure you type that in. New to Kubernetes, make sure you check out the link on the screen, sivo.com/academy. Check out Deckhouse, pretty interesting project, super new. They have open sourced, but it has the power, like Dimitri said, of the past years of experience that has gone into build it. So check that out. And yeah, there's a new channel that I completely forgot to mention. So I and my friend Kunal and my colleague as well, so we have started a new channel in our native language, which is Hindi. So it's called Cloud Shala. So you can definitely check out Cloud Shala. You can search on YouTube. There's one channel and one video, introductory one, and a lot more content is coming over there as well. So thank you so much for tuning in. Thank you, Dimitri, for sharing your knowledge and experience and time. With that, everyone, have a nice day. Bye.
Bye bye.